Okay, today we talk about a complex number. Complex. Okay, here. So I think many people know this one. So I square equal -1, but they don't know where they come from. So in fact, they come from a equation. X squared plus 1 equals 0. How to solve this equation? So we know x squared, but usually large equals 0. So for example, x equal 1. So x squared equal 1. X equal -1. So x squared equal 1. X equal 0. X squared equal 0. But anyway, we cannot make this equation to work. So scientists, mathematics, they create a signal. So how to make this equation work? X squared plus 1 equals 0. So if x squared equal -1. So this equation can be solved here. -1 plus +1 equals 0. So this is definition. Definition is no reason. Just like you call something play, ground, floor, or something you call their this one apple, or cucumber. You can call it dog, no problem. Just only name, the definition. So scientists make this so definition here make this equation work. Okay, so just this equation work. So then they find this definition is super useful. So they said x equal I. So x equal I. So also definition, no problem. X can equal m, x equal n, no any problem. So come here, but you cannot set so many definitions, make people very hard. So many would make me people hard to remember so many definitions. So we can only set this x equal I, x equal I. So x squared equal -1. So I squared equal -1. Okay. So why scientists make this definition? What use for it? So then scientists find this I squared equal -1. It's super useful. They give their definition. So what's this? What's this? X squared equal -1. So I squared equal -1. So I equal square root -1. This is definition. But usually this is not work because when we calculate in real number, so this don't work because you cannot get a square root for -1. But for this definition, it can work. We call this I is imaginary number. Okay, what use for this? We know that this is a coordinate x, y, here 0. So any number you can find and the number line. For example, this 0, this 1, this 2, 1, 2, -1. Also, you can find the fraction. 1 over 3. Also, is a decimal number, 0.3. Repeat. Also, you can find this. Square root of 2. Okay. But the only problem, what is I? Come to I. I is position. Come here. For example, the 1 point is here. So, for example, this 1. And its position, we know that it's 1, comma 1. So, this is the position. How to write it with algebra? Algebra, such like it here is 2, here is 3. 1 comma 1, what is? Okay, so I need to find it. We can write this position with imaginary number. So this one, 1 plus I. I before, you can write 1I, but you know, yi we don't usually we don't write such like x. If 2x, okay, we write 2, but 1x 1 we don't write. We just write direct x. Okay, then we come here. So for example, if we write 1 plus 1, we can get 2. So, but it's different. Here it's not 2. It's position. It's not 2. This position is different. This 1 comma 1 is different with 2. So you must write together. So 1 plus I. This is a number. We call this complex number. So only this part we call imaginary number. So we call this real part. This imaginary part. Together they have name imaginary number. Also, we have another name complex number. This is a number, but this number is different with a real number. Real number you can compare, for example, 3 large 1, large 2. But this here, remember, complex number is different with the real number. So what different? It's a position. It's not a value. It's a position. So you cannot compare. So for example, we use the number, this one, z1 equal 1 plus I, z2 equal this real number, 2 plus 3i. You cannot say z1 large z2, you can say z1 large z2. No, you cannot do that. You cannot compare to position. Okay, here. You cannot compare to position. Only position is different place, but it's not big or small. So that's character of a complex number. But you can use this, but you can do calculation. Such like addition. Z1 plus Z2. So what's the result for Z1 plus Z2? That means 2 plus 2 complex number addition. What does that mean? So you can do, I think you can do calculation you can use for in vector. Okay. Here, we know vector A, vector B, then you get vector C. So about this calculation, we cannot all time draw this. We can use algebraic to calculate, use a complex number. A good example. So we call this coordinate through Descartes connect coordinate. Also here, for example, 1 plus, this position should be 1.1, 1 comma 1. Position is one icon in here. Okay, the position is 1 comma 1. Also, we can write the form for 1 plus I. It's same. 1 plus I. So this write in complex number. This write in a position form. So 1 comma 1. So also, they can instead of vector, we can see here. Vector A equal 1 comma 1. So vector B for example, one comma 2, we let B equal 1 comma 2. If we write in complex number, so we can write Z2 equal 1 plus 2I. Z1 equal 1 plus I. Okay, so here 1 plus 1 and 1 plus 2. Okay, here is 1 plus 2. So we want to make them together. So we know that how to do that. So 1 plus 1, we want 1 plus 2. Okay, it's about here. So we move this move this vector B parallel move to this side, then connect. Okay, so by this one, we draw this. We have to make their algebraic calculation. So A plus 2, vector A plus vector B equal 1 plus I plus here 1 plus 2I. So that's equal 2 plus 3I. So just here 1 plus 3I.